Hey guys, this is our lesson 17.2, defining and evaluating basic trigonometric functions, and this is your lesson for Monday and Tuesday, May 9th and 10th. We're going to be using SOHCAHTOA, which you remember from geometry. I'm going to be using the unit circle with our radian angle measures and our degree angle measures. And let's take a look at a particular angle here. So here is our unit circle. If we wanted to take a 45-degree angle there, we could, and we're going to evaluate sine, cosine, and tangent, okay, of this angle. And what we can do is we can just draw a line going straight down to our x-axis. This is 90 degrees. Our radius, since this is on a unit circle, will be 1. And we're going to find out what the length of these other sides will be. Well, what we have here is a 45, 90 triangle. And we have a hypotenuse of 1. We want to find these other side lengths. They're both going to be equal. And we can use the Pythagorean theorem here. A squared plus a squared equals 1 squared. A squared plus b squared equals c squared. And we'll get 2a squared equals 1. Divide by 2. Divide by 2. A squared equals 1/2. Take the square root of both sides. A equals the square root of 1 square root of 1 over the square root of 2. A equals 1 over the square root of 2, and we don't like to have square roots in the denominator, so we're going to get rid of that. And we're going to have A equals the square root of 2 over 2. Okay, so in every 45, 90 triangle, we have our hypotenuse of 1, and the side lengths are root 2 over 2, root 2 over 2. It's a 45-degree angle up there. So sine of 45, sine is opposite over hypotenuse, opposite over hypotenuse, root 2 over 2, divided by 1. Sine of 45 equals root 2 over 2. Cosine of 45. Well, this is adjacent over hypotenuse. It's going to be this over 1, so root 2 over 2. And tangent of 45 is going to be opposite over adjacent. These are both equal. Root 2 over 2 over root 2 over 2 is going to equal 1. This same relationship applies to this 45-degree triangle. It applies to this 45-degree triangle. And one more. And you can see how this is going to be negative root 2 over 2. This will be positive root 2 over 2, negative root 2 over 2. And this will be a negative root 2 over 2. So these negative and positive signs come into play when we figure out our sine, cosine of the angles. In this case, they were all positive because they were in quadrant 1. Okay, so that was sine, cosine, tangent, and we can use this for all of our 45-degree angles. So this is 45, this is 135, this is 225, and this is 315. Okay, and then we could also write our radians pi over 4, 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. Okay, so sine, cosine, tangent, we could do that for all of these. Just using our SOHCAHTOA, set it up, and we will get our values here. And that's just based off of a 45, 45, 90 degree triangle. So hopefully that's pretty straightforward. There'll be some great Khan Academy videos if that's not clicking for you. But I think this is pretty good, and I think this will help a lot of you out. Okay, so that was one type of triangle that we're going to find using these points. We can make a 45, 45, 90 triangle. We could also make so this is 30 degrees or pi over 6. Go straight down. So this is a 30 degree angle, a right angle, and a 60 degree angle. So we've got a 30, 60, 90 triangle. And we can also get another one of those if we go up to here, and if we make this angle 60, this angle is 90, and then this angle would have to be 30 to make 180 degrees. So we've got this piece. We could reflect that over here. We could also reflect that down. And that actually covers all of our bases, all the triangles we can make. This one is 30, 60, 90. That's 30, 60, 90. Let's just put them in here. This one will be 30, 60, 90. That's a 30, 60, 90. That'll be 30, 60, 90. And that one's 30, 60, 90. So it's a little messy, but hopefully that gives you a feel for what we're doing here. So in a 30, 60, 90 triangle, we know our hypotenuse is going to be 1. We know our angles 60 and 30. We want to find these two other sides. Well, what could they be? Well, there's a fun way to do this. You might remember this from geometry. If you add another 30, 60, 90 triangle right here, we now have 60 degrees, 60 degrees, 60 degrees. This is now an equilateral triangle. So this side is 1, this side is 1, and this side is 1. But notice we doubled this side, we doubled this triangle to put this one here, this red one here. That means the base here is split right in half. It doesn't look like it, but it is. So this is 1/2, and that's 1/2. Okay? So we've got two sides so far, and we want to figure out our third side. Well, we'll just do a little Pythagorean theorem. We'll call this b. So 1/2 squared plus b squared equals 1 squared, hypotenuse squared. 1/4 plus b squared equals 1, minus 1/4 minus 1/4. We get b squared equals 3/4, square root, b equals root 3 over root 4. B equals root 3 over 2. Okay, so in a 30, 60, 90 triangle, the angle opposite the 30 degrees is 1/2, and the other side is root 3 over 2. So why don't we just put a little reference down here? This will come in handy. This is 1. This is root 3 over 2, and this is 1/2. This is our 30, and this is our 60. Okay, and then we found out our 45/90 triangle. If this is 1, we have 2, root 2. Nope, that's not quite right there. It should be root 2 over 2. Okay, so those are our references there. And we're just going to use these relationships to fill in and do whatever it is that they're asking us to do. So, if we were asked to find the sine of 60, cosine of 60, and tangent of 60. This is how we would do that. So we got a 30, 60, 90 triangle. And we know we have a 1 here. We know across from the 30-degree angle, we're going to have 1/2. And the other side is going to be root 3 over 2. Okay, now we're in business. Sine of 60, opposite over hypotenuse. Opposite over hypotenuse. 1/2 over 1, or just 1/2. That works. Oh, that's not quite right. Sine of 60 is opposite